In this video, I want to continue with problem number 64, and the difficulty with this problem is that we're going to have to expand out x plus delta x to the third power. And you might remember that this brings in the idea of the binomial theorem. For example, a plus b to the third power, if you are going to multiply this out, you would have to FOIL. Actually, it's more than FOIL, but you'd have to multiply out these three different binomials here. And it's possible, it just takes some time to do that. And the first two just multiply out to a squared plus 2ab plus b squared, and then we're going to multiply that all by a plus b. And the way that that's done is we're going to multiply every term in the first expression by every term in the second expression. So we're going to do a times a squared, a times 2ab, a times b squared, and then b, etc. So that would give us a cubed plus 2a squared b plus ab squared, and then there will be three more terms with b. So we'll have a squared b plus 2ab squared, and finally b cubed. And when we simplify, we'll end up with a cubed plus 3a squared b's. You have a 2a squared b and an a squared b. And you also have an ab squared and a 2ab squared, which gives us 3ab squared. And finally, plus b cubed. So that really wasn't that much trouble, but just to remember how that went. Now it happens that the coefficients of that are the entries in Pascal's triangle for the third row. If you recall, Pascal's triangle starts 1, 1, 1. We start with the 0 row, then this is the first row, then 1, 2, 1, and finally 1, 3, 3, 1. So we can do this problem a little bit simpler if we know we have a plus b quantity cubed. Then we'll know that the coefficients come from the 0, 1, 2, third row of Pascal's triangle. Then we're going to have a factor or a term ab, a times b, with each of those coefficients. But their exponents are going to be found this way. A is going to start at 3 and work itself down to 0. So you have a to the third in the first term, a to the second in the second, a to the first in the third, a to the 0 in the fourth. Then the b's are going to start at 0 and work themselves up. So you'll have b to the 0, b to the first, b to the second, and b to the third. And when you simplify that, getting rid of anything to the 0 power or any 1 coefficients of 1, you end up with a cubed plus 3a squared b plus 3ab squared plus b cubed. Now you may think that it was easier to do all the multiplying out that I did in red there, but if you had to do this often, the second method would be a lot faster. So let's take a look at 64 in that view. We have the limit as delta x approaches 0 of x plus delta x cubed minus x cubed all over delta x. Alright, so the tricky part is to expand out x plus delta x to the third power. So since it's to the third power, I'm going to write this down at the bottom. We're going to start out with coefficients of 1, 3, 3, 1. Then each term will have an x delta x. Then we'll start with the x's. They start at 3 and work themselves down to 0. The delta x's will start at 0 and work up to 3. Then we simplify and we'll get x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. I'll write that in. We just need to remember to subtract that last delta x at the end. Sorry, the last x cubed at the end. And all over delta x. We'll simplify. Anything without a delta x should 0 out, which the x cubes do. And I'll rewrite this time already factoring out the delta x that we'll need to factor out. We'll get delta x times 3x squared plus 3x delta x, not delta x squared, and then delta x squared. All over delta x, the delta x's cancel. And you can now set all the delta x's to 0, so the 3x delta x and the delta x squared will go to 0, leaving you with a limit of 3x squared. And that does it for this problem.